Managing Kafka in production is one of the hardest operational challenges in cloud infrastructure. Even with managed services like AWS MSK, you still need deep expertise in both AWS infrastructure and Kafka internals to handle incidents properly. I'm going to show you a real scenario, an MSK cluster running out of capacity, causing under-replicated partitions. This is the kind of incident that can lead to data loss if a broker fails. And I'll show you how Kestrel automatically detects this, investigates it, and generates a complete two-step fix. Let me show you the demo environment. I've deployed a minimal MSK cluster using Terraform, intentionally undersized to demonstrate this failure mode. We have a 2-broker cluster using Kafka T3 small instances, which is the smallest broker type MSK offers. With a replication factor of 2, every single partition has to replicate to both brokers. There's no slack in this system. We also have an EC2 client instance in the same VPC as the MSK cluster. I also wrote a high-performance Golang producer for the stress test, which uses 64 worker Go routines with 1 kilobyte messages and ACKs set to 1, meaning we only wait for the leader broker to acknowledge writes. This setup maximizes throughput and puts maximum write pressure on the MSK cluster. I'll kick off the stress test by running the run demo script, which starts the Golang producer and a real-time monitor that pulls CloudWatch metrics so we can see the number of under-replicated partitions. You can see the producer ramping up. We're producing around 70 to 80 megabytes per second to these tiny brokers. Both brokers are now at high CPU utilization, and they physically cannot replicate data fast enough with this write rate, causing under-replicated partitions to go above 0. Within seconds, Kestrel picks up this incident. It correlated multiple signals here: the CloudWatch alarm for under-replicated partitions, the broker CPU metrics, and the cluster configuration. It's identified this as an MSK cluster capacity insufficient incident, meaning this isn't a broker failure or network issue. It's a capacity problem. Looking at the root cause analysis, Kestrel explains that with only 2 brokers and replication factor set to 2, there's no headroom. When both brokers are saturated, replication falls behind. The investigation summary shows exactly which partitions are affected and the timeline of how this escalated. Now here's where it gets interesting. Kestrel understands that fixing MSK capacity issues requires 2 distinct operations. Step 1 is to add brokers. Kestrel generates the exact AWS CLI command. In this case, to scale the number of brokers, we need to run AWS Kafka update broker count targeting 4 brokers. It also generates an equivalent Terraform diff that you can open as a pull request if your team manages infrastructure as code. But here's what most people miss. Adding brokers doesn't actually help until you do step 2. Kafka doesn't automatically redistribute existing partitions to new brokers. The new brokers just sit there idle while the original ones stay overloaded. So Kestrel generates the second step, running the Kafka reassigned partitions tool via SSM on an EC2 instance in the same VPC as the brokers. It creates the topic list, generates the reassignment plan, and executes it, all automated. When you click Apply Fix, Kestrel executes the AWS CLI command first, which is an async operation. It takes about 20 to 30 minutes for MSK to provision new brokers. Kestrel polls for completion, and when the brokers are ready, it automatically runs the SSM commands to rebalance partitions. This is what we mean by bridging the gap between cloud infrastructure and application internals. Existing monitoring tools would just alert you that partitions are under-replicated. You'd still need a Kafka expert to figure out why and how to fix it. Kestrel gives you the complete picture and the complete fix. Whether you want to run it via CLI, push it through your infrastructure as code pipeline, or let Kestrel apply it directly. If you want to try this yourself, the demo repo is open source. You can deploy it in your own AWS account and connect it to Kestrel's free trial.